Good afternoon. Welcome back. We are starting. Take your seats. Great. So, good afternoon again. Welcome back to Devoxx Poland. I'm Alex. This session is about serverless architectural patterns on Amazon Web Services. I am a technical evangelist at Amazon Web Services. I'm Alex from Italy. I've been working in startups. I'm a web developer, data scientist, software engineer, depending on the team and the situation and the day of the week. I also organize some serverless events around the world, but if you want to organize one in Poland, they are called Serverless Days. We might have one soon. Before joining AWS, I was a customer for more than 5 years, a happy customer of AWS, so I know what it feels to be on the other side. If you have any questions about any of these topics, just stop me afterwards. The agenda for today is very simple. I want to very quickly introduce serverless for those of you not familiar with the term or or at least with the way that AWS created and defines the term. How many of you are familiar with serverless computing or have even used it? Okay. I would say 75%. So very quickly, I promise a bit of a foundation about serverless, the way we intend it. And then I want to discuss not 4 patterns, but 4 categories of architectural patterns for different scenarios and use cases. So I'll touch on 4 macro categories, touching on web applications or microservices and APIs, on stream processing, data processing in real time most of the time, data lakes or data analytics, and machine learning. So these are 4 macro areas where serverless can help you be faster, be cheaper, be more flexible, be event-driven. There are many advantages, I would say. And we'll look at different use cases and different other services that you can integrate into your patterns. So let's get started with the super quick introduction, I promise, about serverless. So first of all, I want to introduce the concept of compute spectrum. A lot of people think serverless is black or white, 0 or 1. It's actually a spectrum. Some services, tools, solutions are more serverless than others. So we like to define on EC2 or on cloud instances, whatever is, we give you an instance, you install whatever you want on it. So that's the opposite of serverless, because your main level of abstraction is a virtual machine or an instance, and from there up, it's your responsibility to build on top of it. That was announced like 13 years ago on AWS. We called it EC2. There is a middle layer that we called managed services. Most of the middle and right sections contain managed services, but here in the middle you find stuff that is not entirely serverless for different reasons, either because these services have an hourly cost, independently of whether you are using them or not, like Amazon RDS, for example. It's a relational database service. You can spin up an RDS cluster, whether you use it or not, you're paying it by the hour. So by the way, the abstraction layer is you have a database cluster. So you still have to deal with machines or instances or the concept of a cluster. On the right-hand side, you have the fully serverless services that allow you to really stop thinking about servers, machine, operating system maintenance, patching, and all those things, because there's no server, there's no cluster, there's no container even that you need to take care of. So that's the big difference. Of course, the enabler for this, let's call it serverless revolution, that we started in 2014 was AWS Lambda. Lambda was the compute part, actually the first one that we launched in 2014, and that kind of changed the game, because now you can integrate your compute logic and think about events and stop dealing with patching operating systems and maintaining clusters of machines. As a developer, that probably you were not doing that, but somebody else in the organization was, or some vendor was doing that for you. The idea is that serverless can give your developers or yourself full ownership on the code that you're building, deploying, and operating in production. So that's what we mean by serverless. The idea that you do not manage, maintain, patch, or own a server or a container. So there are some other players that think containers are or can be serverless, or serverless on Kubernetes. Well, if you have to own a cluster, we think it's not serverless. So subjective reactions to technology. I tend to agree with that, because as a developer, I don't want to operate a cluster to run my function as a service on top of it, but that, I understand, is subjective. The benefit or the consequence of the cloud vendor dealing with all the infrastructure, networking, operating system security, is that you get this flexible scalability, and completely flexible, meaning you can go from 0 to hundreds of thousands, if not millions, of concurrent invocations, and then down back to 0 if nobody is invoking your functions, if there is nothing happening in your account, in your environment. Another consequence is that, if you build your applications using instances or containers, you have to make sure that you use multiple availability zones, which is this concept of a logical set of data centers inside of an AWS region. And you take your instances or your containers, you have to deploy them into multiple availability zones to make sure you are highly resilient and available. With serverless, that's also done by us, so you don't have to worry about all of that. So that's why a lot of people look at the pricing and they say, hey, 1 hour of Lambda computation is more expensive than an hour of EC2 computation. It's true, but it's true because it contains more features, more heavy lifting that you don't have to take care of yourself, or your team doesn't have to take care of yourself of. So think about that as well when you look at pricing and compare. And actually, pricing is one of those things that change a lot. We were discussing this morning during a workshop that the pricing model of Lambda is very different from the traditional instance or container base, because you're not paying by the hour. You're paying by the 100 millisecond interval, okay? So if your functions are being invoked or executed for, 210 milliseconds, okay, you're paying for 300 because that's the next interval. But when you think about performance and optimization, if you can shave 20 milliseconds off those 210 milliseconds, you go down to 190, and that means you have cut 30% of your cost of execution just by cutting, less than 10% of the performance, or of the execution time. So it's a different way of thinking about cost and cost optimization, because then you can look at your features and go and optimize those features that are more expensive to you or expensive to your customers if you also apply a pay-as-you-go model to your customers. So it's changing a lot the way people and developers and companies think about it. There are a few different things that happen behind the scenes when you deploy and run these Lambda functions. And we can divide it into what we call a cold start and or a warm start. So what happens is that you provide your code in a deployment package. That's just a zip file with your code, whatever language. It could be Java or Node.js or Python, Go, Ruby, PowerShell.NET, whatever. Some customers are running their COBOL code inside Lambda. Okay, you can run everything you want on Lambda. Since a few months, you can build your custom runtime even. So what we need to do, as you can imagine, is we need to take that code, bundle it somewhere, start either a container or a runtime. Actually, it's not a container. Recently, we announced that we are using a micro VM technology written in Rust that's also open sourced. We call it Firecracker. But anyway, we inject your code into this environment, into this container micro VM, and then we can finally invoke it. Okay, so everything that happens inside the cold start, that happens every once in a while, right? You haven't invoked your function yet, you run it, there is a cold start. From that point on, every time you invoke your function, it's warm. Even though you're not paying for it, it's warm. And you can just run it, and all we need to do is invoking your function. What about memory and CPU and network? Well, I like to call it power because there is not such concept with AWS Lambda. You don't have 3 or 4 handlers. You have only one. And we call it memory. I like to call it power because if you give it more memory, you also get more CPU, more networking, more everything. And this is very important because if you have a very CPU or networking or memory intensive workload, giving it more power will make it run faster, as you can imagine. But the big difference is that if you make it run faster, it will be cheaper as well, because you're paying by the execution time. So if you give it 10 times more memory and it runs 10 times faster, you're paying the same. Okay, this is another big difference in the way you think about cost optimization and performance. I like to say that this never happens in the history of IT, that you can run something faster and pay the same, or even make it cheaper. Typical instances, if you want it to run faster, give it more resources, and it becomes more expensive, because you pay by the hour anyway. Anyway, a lot of people try to guesstimate or randomly estimate their resource, their power allocation, and that's why last year or a couple of years ago, I think, I created a tool called Lambda Power Tuning. It's an open source project that basically defines state machines and takes your functions as input. It will run it through different configuration, power configuration, and as an output it will tell you, hey, this function is cheaper or more performant if you run it with this configuration. And many customers are actually using this as part of their continuous integration, continuous delivery pipeline. So they update the code, build the artifact, optimize it for cost, and then deploy to production or staging or development. If you want to use infrastructure as code, that's also available with CloudFormation. There is even a serverless special transform that we call AWS SAM, the serverless application model. That's also a squirrel that allows you to define serverless resources in CloudFormation in a much more readable and intuitive way. This is also all on GitHub, so you can open issues, have a look at open PRs, and contribute and help the team move faster. Well, since a few months, even AWS Code Deploy supports Lambda. So you can even do blue-green deployments and say, hey, this is a new version of my code. Give it only 10% of the traffic. If anything goes wrong, roll back to the previous version of the code. And it's all built into Code Deploy and AWS Lambda. So it's becoming a mature ecosystem, I would say. A couple of years ago, I started using Lambda in 2016, about a year and a half, and everything wasn't there. Now I would say it's pretty mature and stable. So let's get into the first pattern that I want to tell you about. So web application, microservices, APIs. This might be one of the most common pattern or the most common category that developers used and approach serverless for. So this is the typical architecture for a website or an API. What you do is you separate the front end at the top. It's usually in the modern applications a static website on top of S3, and you want to distribute it using a CDN, for example, Amazon CloudFront, so that everybody around the world will get low latency static website. And then you want to have the dynamic part at the bottom as a set of dynamic APIs. We have a service called API Gateway. It puts a RESTful interface on top of your functions. Lambda, well, that's whatever code you have deployed to Lambda. And then you probably have a database. Could be DynamoDB, could be it's a NoSQL database, could be RTS for your Postgres or MySQL or even Oracle databases if you like. But this is the starting point. There are a few options here. So the first options I want to tell you about is about API Gateway. So within API Gateway itself, it's a very, it has like 2,000 features. I want to tell you about one of the most recent changes, which is the endpoint type. There are 3 different endpoint types with API Gateway based on the needs, based on the architecture, based on the use case. So the first one that we actually announced back in 2016 is the edge optimized. This is for global kind of applications. You have users everywhere around the world, or you don't even know where they are. You don't care where they are. And you want to optimize latency for all of them, no matter where they are. So what we do is we put a CDN in front of it, and without caching, but it helps you speed up the network because you're using the Amazon global network instead of going through the internet. So a user in Sydney will get into the Amazon network in Australia and go all the way to your function, maybe in Oregon or in Dublin. This is another way, another optimization you can do is instead of having CloudFront serving only the static website, you could have CloudFront in front of both the static website and your backend. So this helps a lot of customers solve issues, for example, with CORS, the cross-site scripting kind of protocol. So if you have both the website and the API on the same domain using CloudFront, it kind of simplifies a lot of problem. Plus, it allows you to use some of the very specific features that CloudFront offers. For example, Lambda at Edge. Lambda at Edge it's like Lambda, but it doesn't run in the data center itself. It runs at the edge on the CDN. So you can be as close as possible to the user, and there are more than 150 of these edge locations around the world. So you can use it to add security headers. You can use it to validate authentication at the edge instead of overloading your origin, your servers, or your Lambda functions. So it comes with all the interesting features, or even rewrite URLs or do A/B testing, cookie-based A/B testing. It comes with all sorts of scenarios. The second endpoint type is the regional endpoint type. So here there is no CDN. You deploy your API endpoint to one region. Could be Dublin or Frankfurt or Oregon, Virginia, Sydney, wherever. There are 21 regions today. And this is useful for a couple of scenarios. The easy one is that, well, this endpoint is only used by regional services, like your instances inside Dublin need an API endpoint, and only they will use this. So why having a global one if the only client is within a region and you know it? So regional endpoint is a good fit for those. The second reason you may want to use it is to build multi-region kind of architectures, like in the diagram here. Imagine you want to do regional failover or disaster recovery, or even just to improve the availability of your services. You can improve your availability of roughly 10x if we have two regions instead of one, depending on the service you're using. But if you use API Gateway, Lambda, and Dynamo, for example, that's roughly the availability increase that you get. As far as time that you can allow to be down in a year. But you can deploy the same architecture, API Gateway, Lambda, and Dynamo in two different regions, and maybe do latency-based routing, or do round-robin routing, or even do availability-based routing. So if a region goes down, never happens, but you have another region to fall back to, disaster recovery. So regional endpoints are a good fit for that. Here it's the same. If you want to put CloudFront in front of it, you want to use Lambda at Edge, or you want to use the web application firewall to avoid SQL injection, or to write your custom web application firewall rules, that's also an option. There is a third endpoint type that we call private, and this is specifically designed for endpoints that are not available from the internet, but you want them to be available only from a specific VPC, a virtual private cloud, your own private network inside the AWS cloud. This is even useful if you want these APIs to be invoked by your on-premises data center, if you connect it using AWS Direct Connect. So interesting scenarios, 3 different options for your workloads. What about security? Let's go back to the traditional, typical architectural setup. Where do we add security in here? So first of all, you want to serve static content using encrypted connection, using TLS, and CloudFront gives you that. You can even enforce HTTPS to be used instead of HTTP. But CloudFront itself gives you additional features. For example, geo-restrictions, you can sign URLs if only specific users or clients can access. It even does DDoS protection for you. So it will cut off all the traffic that's supposed to be a DDoS, and you're not, your functions and your website and everything is not hit. So even from a cost perspective, it will help you with that. S3 comes with all sort of policies and features to enable security, but if it's a static website, probably it should be open to the world, but you have all the fine-grained controls over who can read the data or not. API Gateway, and I have another slide on the topic, has very sophisticated authorization and authentication mechanisms. So you can provide specific clients or customers or your customers access to different endpoints on a one-by-one basis, for example. But even comes with throttling method by method. You can specify cross-account resource policies to grant access to specific methods or policies or resources. And usage plans. Usage plans are interesting because you can have you can group API keys based on a usage plan, like Platinum or Bronze, or you give it whatever name you like, and then you can group your API consumers based on this usage plan, and they will have different throttling and rate limiting policies. For example, you can say this group of API keys can invoke my service or this function, this endpoint only, 100 times a month. Okay, that's like the freemium plan. And then the platinum plan, okay, these have 1 million invocations per month, but maximum 10 invocations per second. Okay, you can do this kind of checks, and it's all managed for you. You don't have to re-implement it. And while Lambda, it comes with the concept of function policies. So if you want your functions to do anything, like reading from a database or writing into a queue or a pub sub, well, you have to specify that. Otherwise, your functions can't do anything. So that's secure by default, let's say. But then you have all sort of tools like environment variables, services like the secrets manager or the parameter store to store your parameters, your secrets, your tokens, whatever. Dynamo, well, if you don't care about SQL, if you don't like Dynamo, a lot of people don't like Dynamo. I think it's pretty awesome, especially if you have large-scale key value kind of use cases. Like we use it a lot at Amazon. Actually, Amazon.com is powered by Dynamo. I think it's 60 or 70% of the queries at incredible scale. But it comes with encryption at rest. You have VPC endpoints, and even the permission that you give your functions to read Dynamo. You can say this function can read only this table, only these columns or these fields of the table. So it can be very fine-grained. Or you can say you can only write and not read if it's a data ingestion pipeline, for example. So when it comes to security, you have all the tools that you need to secure your apps. Authorization, that's an interesting topic. There is a full workshop on it. We did it this morning. API Gateway allows you to even customize the authorization mechanism. So you can build your own custom Lambda authorizer. And you can say, when my client invokes the API Gateway, run this other Lambda function first. That will maybe check a token using a SAML provider or some sort of identity provider. Only based on the result of this authorizer, your API request will proceed to your Lambda function. And optionally, you can integrate with all third-party services, or you can even store additional information if you want to store information about company or groups or whatever additional information you need. So this very allows you to do very fine-grained authorization policies. And what this Lambda authorizer returns is actually a policy that says this invoker, this client, can invoke this endpoint but not this other endpoint, or this method like post, but not this other method like get. So you have super fine-grained control. And that was it for pattern one, one category. Let's move over to pattern two, data processing, or stream processing, which is getting very popular. From what we see from customers, we have designed 4 services that help you with that. I want to focus on the right-hand side 3. So I will skip Kinesis video because it's a bit specific on video content. So I'll tell you about data files, data streams, and data analytics. These are 3 services that help you with data ingestion, data processing, and real-time data analytics. My favorite actually is Firehose, Kinesis Firehose. It allows you to ingest data, so you have some sort of record producers or data producer. You put records into Firehose, and you configure Firehose to serialize and store data on different destinations. Destination could be S3, could be Redshift, our data warehouse. It could be Elasticsearch if you want to search the data, like full text search. But additionally, you can even say, hey, before writing the data, invoke this Lambda function that is able to manipulate, filter, extend, enrich, or validate the data that is passing through. And by doing that, with a couple of checkboxes or configuration parameters, you can say, hey, also compress the data, encrypt the data. With a third checkbox, you can even say, hey, transform the data to be in columnar format, so I can easily query and analyze the data at scale later on. So it's super powerful service. I really like it. If you want your API, your data producers to use a RESTful interface instead of the SDK, you can put an API gateway in front of it, and there is a direct integration between the two that you can use. Or you can even use CloudFront if you want to have Lambda attached validation in front of it. Like, these are alternatives that you can use based on use case. So there are two parameters that you can tune. One is the buffer size. When does the data gets written? After 10 megabytes or after 60 seconds, you can choose these two parameters. You can enable compression, Parquet format. Optionally, you can even enable a backup of everything. Store a backup of the raw data in this S3 bucket. So maybe you can replay this data in a dev environment or in a staging environment. So pretty powerful. There's another service called Kinesis Data Stream, and this was announced before Firehose. But we saw that a lot of customers were doing data stream, Lambda function, right into S3, or data stream, Lambda function, right into Elasticsearch. And that's why we created Firehose. So those scenarios are covered by Firehose, but if you have any other scenario that does not integrate well with Firehose, you can use raw data streams. Data streams, a lot of people think they are a queue. They're not actually a queue, because when you take a message out of a queue, the message disappears, and that doesn't happen with streams, data streams. It's more similar to Kafka, if you want. How many here use Kafka? Okay, how many here use Kinesis? Okay, it's similar to Kafka. So the idea is that you have this data retention period up to 7 days. So the data is there, you can attach new consumers, and they will read all the data. And if you have multiple consumers, they will all read the same data. So you have multiple data pipeline in parallel, for example. In my opinion, this is not fully serverless, because there is a number of shards that you need to configure. So a shard is not a server, but if you think about it, it kind of is. So based on number of shards, you get a given throughput of read and write throughput. You can even configure the batch size, because your functions are fetching data from the stream in batch. So you can say fetch 50 records at a time, or fetch 1,000 records at a time, based on your needs. It's important to remember, if your function fails while processing, there is an iterator concept. So the data is not lost. You go back and fetch the data from the stream until it's fully processed. So you even have order management there. In some cases, though, you want to process as fast as possible. So instead of having this one function that's pulling data and maybe processing it right there, you want to increase the throughput, because you want it to be as much real time as possible. So some customers are using this pattern that we call fan out. That's basically, you have one first dispatcher that's fetching everything as fast as possible, and it's passing it to a second layer of functions, if you want, that's actually doing the hard work. This allows you to increase throughput if you have processing latency issues, for example. If you have a lot of data coming, you probably want to do this. There is even a library that allows you to do that. Basically, you do nothing. You just specify the processing logic, and the dispatcher is implemented for you. The third service that I want to tell you about in the Kinesis family is data analytics, Kinesis data analytics. So this is for use cases where you not only want to stream data and store it somewhere, but also look at it as it flows and do some statistics, aggregations, and take actions on those. So let's imagine here that, I don't know, we have some IoT devices on the left, and they're pushing data like temperature every 10 seconds, thousands of them. And we have this Kinesis data analytics application that's running moving window or tumbling window SQL queries on top of this data. And based on the result, maybe you're computing averages or computing the max, min, whatever. And let's say if the temperature of a group of devices, could be a room, is above a given threshold, you want to raise an alarm or get some people to actually go and see what's going on. And you can do that with the Lambda function and say, give the output of this query to Lambda. Lambda will check the threshold, maybe send a notification or store the data somewhere. How does this work? Well, you do that with an SQL query. You can actually also use Java, but I think it's easier to visualize and understand with an SQL query. What you define is a sort of tumbling window or moving window. You can choose which one. Tumbling means non-overlapping, so it's not moving. It's one after each other. It could be 10 minutes, could be 10 seconds. That's up to you. Here it's 10 minutes. For our use case, you probably want to detect if the temperature is too high every, I don't know, 30 seconds, not 10 minutes. And then you can do all sort of aggregations, summing, averaging, that's an SQL query, whatever you need to do. The output of that can be sent to an output stream or a Lambda function or whatever you want. So you can act on it. Third pattern, data lakes. How many of you know what's a data lake? I haven't heard a clear definition in the last 3 years. Okay, I'm not trying to give you a clear definition. I want to tell you why they are useful and what you can do with them and why you can do it in a serverless fashion. So the idea, the characteristic, the goals are the same with the ones of data warehousing or data analytics in general. So you want to collect data, analyze data, find some insights, maybe take some decisions. That's what good companies tend to do. The difference is that you can store all sort of data, not only structured, but also unstructured or semi-structured. The big deal is that storage and compute are completely decoupled. So you can have petabytes of storage or petaflops of compute completely independent from each other. In a traditional world, if you want more compute, you need to add more servers. That also means more storage. It's not really decoupled. And that's a problem for cost perspectives or for efficiency perspective. The ingestion should be as fast as possible. That's your goal. The second huge difference is that the schema of data lake is on read. So you define the schema of the data not when you write it, but later when you read it. That's a big difference, and it's super confusing the first time you hear about this. The data lake concept is not an alternative. It's supposed to complement, to help, to support data analysis teams, and sometimes you want to have both a data warehouse and a data lake in the same system. If you build a data lake on AWS, it's everything revolves about around S3. So S3 is our object storage. You can put objects, files, images, or JSON and CSV and Parquet records inside it. So then you have all sort of tools and services that help you catalog and discover and process and secure and even anonymize if you have like GDPR compliance issues. Everybody does. So there is a service called Macy that will go and anonymize your data on S3 already. We have seen the ingestion part using Kinesis. So you can simply store everything on S3. You ingest data, CSV, JSON, even text, whatever. And then you can go and analyze it. So I want to tell you about this service called Athena. It's my second favorite service after Firebase. So what you can do with Athena, basically after you have your data on S3, you catalog it. There is another service called Glue that will automatically discover your data, build virtual tables, and do some magic for you. And once you have these virtual tables, without any data movement, data is still on S3. These are virtual tables. Athena will go and query the data and will give you an SQL interface on top of that data. And then the output of Athena, result set, Maybe you want to analyze it, visualize it, maybe with another service called QuickSight. Sorry for the number of services, but we are Amazon Web Services. That's what we build. We have 165 of those. So that's the interface that Athena gives you. You can put a query, run it, get some results. How many of you know Presto? PrestoDB? A few? It's an open source database, and that's what's behind Athena. The big difference is that Athena is managed. Athena is, let's say, serverless, meaning that you don't pay by the hour. It's actually fascinating because you pay by the amount of data that your query is scanning. So if you scan 10 megabytes, you pay for 10 megabytes. If you scan 10 gigabytes, you pay for 10 gigabytes. This is very different from any data warehouse or database solutions anywhere else, as far as I know. So let's take, for example, this data set. It's the Google Ngrams. It's actually available already on S3. We pay for it. You can just query it. If you run this query, it's traditional, regular SQL or Presto SQL. This query will run for about 44 seconds because it's scanning, I think, 160 gigabytes of data. And if you are familiar with data warehousing, 160 gigabytes of data would take you, I don't know, an hour and a half, or at least 20 minutes, let's say, to query, depending on what you're doing. The cost of the query is only 85 cents because the pricing is $5 per terabyte per month. So again, the idea is that if you run 0 queries, you pay 0. If you run 1 query over 170 gigabytes, you pay 85 cents. You can do your math and see how much data you're scanning per month. It's not too hard. There are a few best practices here too. If you want to store data in that format to create partitions, and the best thing about Firehose, Kinesis Firehose, is that it's doing that already for you. So you want to have yearly, monthly, daily, especially partitions, especially if you are into like IoT data or time-sensitive data. You can use columnar formats. If you have Parquet or Avro or ORC, it will optimize a lot because with columnar formats, if you only select a couple of fields over 20 fields that you have in your data, guess what? You will scan less data and your quiz will be faster and cheaper. So using columnar formats will help you with cost and with performance. It's another serverless thing. And the best thing is there is no cluster. Data is on S3. We parallelize the computation over as many machines as possible, potentially. And you don't even see those, okay? That's the magic. Some companies are even implementing MapReduce with this concept of data is on S3. I have Lambda splitters and mappers and reducers on top of S3 and Dynamo. There is actually the University of Berkeley in California that implemented Pyren. It's a library on top of S3 and Lambda that gives you up to 40 teraflops of computing using, the highly parallel capacity of S3 up to 700 gigabyte per second, read and write, blah, blah, blah. So actually, and this is newer, they built another system on top of it, like a purpose, like a specific language that allows you to do linear algebra on top of this MapReduce architecture. So super cool science stuff. Last patterns, we have another 11 minutes. I can do it. Machine learning. How many of you are doing machine learning today? No shame? 3. Cool. I hope by the end of this last section you will be encouraged to try some machine learning yourself, because it's not only for data scientists, it's for everybody. And one of our goals is to democratize the algorithms and the technologies that we've built. That's the stack that we like to talk about. Today I want to tell you mostly about the top of this stack, because at the bottom you have stuff for raw machine learning, hardcore machine learning developers. In the middle area you have data automation and machine learning deployment automation, like machine learning ops, if you want, which we call SageMaker. But at the top, okay, those, I don't know, few services at the top, everybody can use them, okay? They are an API call away. No machine learning required, no machine learning experience. required. And those services up there will do stuff for you, like analyze images, or generate audio from text, or generate text from audio, or build your chatbot for you. You just provide some sentences, you have a chatbot, or even analyze documents and extract structured data. All sort of machine learning capabilities that you don't want to reinvent the wheel. You want to use them. It's an API call away. It's serverless. There is no server or cluster to manage, and it's pay as you go. If you don't call it, pay 0. If you call it 2,000 times, you just pay that at the end of the month. I want to show you a few different things you can do using those services, and I hope by the end of this section it will spark some new ideas that you can use this stuff for your own use cases, for your own company, with your own data. So let's imagine that some folks are uploading data on S3 using a mobile or web application. Lambda has a built-in trigger that you can say when a new file appears on S3, run this Lambda function. That's one of the first triggers that we implemented. And then there is another service that we call step functions that allows you to build visual workflows or virtual state machines. And in there, you can do a lot of stuff in parallel and then converge to a final state, for example. So for example, here, let's imagine that those files uploaded on S3 would be images. And we can use Amazon recognition with a K to detect the faces, detect the labels, and detect if it's a moderated, an image that should be moderated, or detect the text. You can do optical character recognition on top of the image. And we can do all this stuff in parallel in our state machine, and then take the result, maybe store it in DynamoDB or in Elasticsearch, and provide some search functionality on top of those images that users have uploaded. Or maybe, you know, imagine we have videos and audio and images all together. So in this architecture here, we have a web interface. We allow people to upload images and video and whatever they want. And using the same pattern of Lambda and step functions, we can do 3 different things in parallel. So at the top, we want to use recognition video to actually analyze the video and find objects, find the activity that's been performed, if there is someone running, walking, blah, blah, blah. In the middle branch, we want to transcode that video, maybe for different devices and different resolutions and different capabilities in the device. And in the third branch, at the bottom, we want to transcribe the audio channel of the video and go and do some text analysis on top of it, like sentiment analysis, key phrases extraction, all sort of features that Amazon Comprehend gives you. And then we can take all the output of these 3 branches and store it on S3 or an Elasticsearch. And maybe with the top branch, we provide, again, search capabilities on top of these media. This is actually not a dream architecture. You can deploy it with a couple of clicks. It's a media solution that is available and already implemented. I want to give you one last example of what you can do with machine learning for your own company. How many of you know Amazon Connect? It's a very new service. I didn't know it 6 months ago. Nobody, great. You are in the right place. So Connect is basically a contact center as a service, okay? Like people call you, you want to solve their problems, blah, blah, blah. You can record calls, you can do real-time analytics, and you can integrate it with machine learning. So let me show you an example. Imagine that we have a customer that's calling us because, I don't know, we are a healthcare institution and they need to reschedule an appointment. So they call us or they send a voice message and they say, hey, I need to reschedule my appointment for next Thursday, whatever the reason. Then we can use Amazon Connect to deal with the audio part and to actually have people talking to a service, but then we don't really have to have an agent, a human agent behind it. We can use automation. So maybe we want to use Amazon Lex, which is our chatbot, or better, our conversational interface builder that allows you to fetch the right information from that audio message or text message or call, It will find next Thursday, it will find a medical appointment, whatever, and it knows what to do. It passes the information to Lambda. They will store the new information on Dynamo or on MySQL, and then send a push notification back to the device. So we have automated, customer service or healthcare, customer support, whatever. Another use case, I also had those. Yes. Another use case with actual people, so they can talk to each other. Imagine you have salesmen or salespeople in your organization, and they're talking to people, because that's kind of what they do. So you have customers and like salespeople or customer support agents, and they're talking, they're solving problems and generating business. You can do a few things here. So first of all, you can trace, you can store all the contact trace records, which means which call, at what time, how long it was, all the meta information about the call, and store it on S3. And that's one-click integration. You pass it to Kinesis Firewalls, that's what we have seen, and you have it on S3, compressed, encrypted, ready for analysis. You can do the same with their actual audio recording of coming from Connect. And you can take that, spin up a Lambda function, state machine using transcribe, and store on S3 also the textual transcription of what was recorded. And transcribe is already smart enough to detect multiple audio channels. So it will give you speaker A and speaker B, so you know who is the customer and who is the agent. And after that, you can go on and spin up another Lambda function and maybe use comprehend to do sentiment analysis and, I don't know, maybe prioritize issues and conversations based on the emotion, whatever, of the last 20 seconds. If it was abruptly interrupted with bad words, probably that's, you will detect negative sentiment and you want to act on those and prioritize those. Well, we ended up with a lot of data on S3, and that's a pretty good candidate for a data lake. And so maybe you can use Athena to analyze and see what's going on, and we can visualize the data using Amazon QuickSight, which I didn't show it to you today, but it's basically a point-and-click data exploration, data visualization tool. You connect it to like 20 plus data sources, and you can visualize stuff and build charts, export charts, integrate charts in your own wiki or in your own internal websites. That was a lot of information. We have 2 minutes left, maybe for a question, and now it's you. Go and build something awesome. Thank you for coming. If you have any question, throw it now, or you can talk to me later. It only so Amazon Lex only supports English right now. We are working, you can't imagine how hard to support more. Thank you for the question. No worries, I'm here for questions if you want. Thank you again.